Welcome to our video on inquiry-based science education in the foundation phase. We'll explore how this approach engages young learners in scientific questioning, exploration, and experimentation through hands-on activities and guided discovery. Inquiry-based science education, or IBSE, encourages young learners to develop their curiosity and understanding of the world. This is achieved through active engagement in scientific questioning, exploration, and experimentation. One activity to foster inquiry is exploring plant growth. The objective is to understand what plants need to grow. Learners use seeds, soil, water, and sunlight to observe and record plant growth under different conditions. In this activity, learners plant seeds and place them in various conditions, such as with or without sunlight and water. They then observe and record the growth of the plants over time, discussing the necessary conditions for growth. Another engaging activity is investigating materials. The objective is to explore different materials and their properties. Learners use various materials like wood, metal, and plastic, and observe their reactions when submerged in water. Learners predict what will happen when different materials are placed in water. They then submerge the materials, observe changes, and discuss which materials absorbed water, floated, or sank, categorizing them based on their properties. Observing weather patterns is another exciting activity. The objective is to understand weather changes and patterns. Learners use a weather chart, thermometer, and rain gauge to observe and record daily weather. Learners create a daily weather chart, observe and record the weather, measure temperature with a thermometer and rainfall with a rain gauge. They discuss the recorded data and identify patterns over time. Through these activities, learners understand how weather affects our daily lives and activities. They learn to observe, record, and discuss weather changes, fostering a deeper understanding of weather patterns. Inquiry-based learning involves formulating questions, investigating phenomena, constructing new understanding, and reflecting on findings. This dynamic approach engages learners in active exploration and inquiry. When exploring physical phenomena, start with open-ended questions to spark curiosity. For example, ask, what happens when we mix different colors? This encourages learners to think and predict outcomes. Next, conduct experiments and encourage learners to make predictions and test them. For instance, mixing primary colors to see what new colors are created. This hands-on approach enhances learning. Collecting data is crucial. Have learners observe and record their findings, such as drawing the results of their color mixing experiments. This helps them understand and remember the concepts better. Facilitate discussions where learners share their observations and draw conclusions. For example, talking about how primary colors mix to create secondary colors. This reflection deepens their understanding. Encourage learners to apply what they've learned to new situations. For instance, using their knowledge of color mixing in art projects. This application reinforces their learning and makes it relevant. By incorporating these activities and approaches, foundation phase learners can develop a deeper understanding of scientific concepts. Active exploration and inquiry make learning engaging and effective.